Okay, always read slow. You don't go fast. I think I can't remember in this class if I pointed out that on the ACT to score high, to score like in the 30s, you have to get nearly every problem correct. On this test, the AP test, there's 108 points possible. If you can score a 4, every university I've ever checked, you'll get the maximum credit. So a 5 is great because you want to do the best you can, but 4 is sufficient. Like you won't get any more credit for a 5 than a 4. And to earn a 4 on the AP test, this number will go up by 1 or 2 points year by year, but not a lot more than that. You get 60 out of the 108 points. So you can miss 48 points and still get a 4. So you don't want to go fast on the AP test. You want to go slow. Because it's way more important to get points than it is to try and get it all done. There's no reason to get it all done. You don't need to. So anyway, read slow. Graph of F. That's it. Then they give a formula for G. They say find G of 0. So just like problem 1, I just used the formula. So G of 0 is going to equal the integral from -3 to 0, f of t dt. Questions or anything anyone would like to talk about? Well, first thing I notice is this integral is going backwards, so I'm going to change that. So if I swap the limits, oh no, my bad, it's going forwards. That was a mistake. You're all like, what's he doing? Strange fellow at the board. Okay. Good. So we're just -3 to 0. So I look up here. 1, 2, 3. Draw a vertical line. Because we're starting at x equal -3. We're going to 0. We're integrating f. So the space I'm looking at is what I've now surrounded in blue. You want me to talk through that?
It could also be like whatever, like x is, maybe 3 times x, that kind of rule. Could it be like
Definitely, it's from x equal -3 to x equals 0. And because we're integrating f, I got to do this. So this is the space. It's always the space between the axis and here.
Wait, so did we get the -3 from like the -3 to x?
Yes, thank you. So the formula says you want to find any value of g, just use this formula. So I did. I want to find g when x is 0.
Oh, okay.
So does that make sense?
Yeah.
Points. Anyone else? Get back to the flashcards. So I remember from my flashcards that one way of calculating an integral's value is geometrically. Right here. So I'm going to find the integral using this. This space, if you like remembering the area of a trapezoid formula, go for it. I prefer rectangles. The area of that pink rectangle is 1, 2, 3 by 1. So the area of the pink rectangle is 3. Hence, the area of the triangle I'm interested in is 3/2. You don't need me to talk through that again. Oh, please.
Well, how do you find the height like the 1? Because it's like 3 long, I get that. It's like,
Oh, right here it says 2 high.
Oh. Oh, okay.
You good?
Yes.
No, good question. 2 point. Anyone else? So what's the area of the rectangle on the bottom? Just say it. 3. So this integral has a value of 3 plus 3/2, so it's 4.5, 9/2. We want to talk about that. trying to get everyone to see that on the homework tonight, you don't worry about what the problem says, no matter how weird it looks. You just work the problem.
Is a fraction or a decimal less used?
Either one. They don't care. So you can write this. I'm not a big fan of a mixed number. It just looks kind of, I don't know, just don't like them. But that's fine. But either one is fine. I have found that when you're working a problem, if you can't use your calculator, fractions are typically easier than decimals. But that's just preference. 2 points. There we go. We need to find g prime of 0. So, just like before, we have a formula for g, so we use Marin's advice. We take the derivative first. Waiting for the copy to work here. Maybe it worked and I just didn't see it. Yep, we're good. So I need to take the derivative. So I need to find g prime of x. So I want d over dx. Okay, remember, everybody look up. This part's really critical. Like, you must note that we are taking the derivative of g. Therefore, this has to be dx, because g is a function of x. You don't worry about the t here. On a limit problem, it has to be in terms of the limiting variable. So I'm taking the derivative of this. So I use my green sheet. Green sheet says, take this, plug in the upper limit. Multiplied by d over dx of the upper limit. Subtract, same thing for the lower limit. Questions? This is 0, this is 1, so I figured out very nicely that g prime of x is just out. So g prime of x equals 0. Don't say it out loud, please just raise your hand if you know the answer. What goes here? Feel free to talk to each other, but we got to get more hands here. So it says here, g prime when x is 0 doesn't become f of 0, it's just they're the same. It's the same as the value of f when x is 0. So what goes here? No one need fear. It's not. Sophie, what is it? 1. Please raise your hand if you agree with Sophie. 0.2 for Sophie. Okay. We're done. 2 points. Questions? Please. Gotcha. Good. So we're using this. So you've got dx, an integral of -3 to x of f of t. So the rule says this is the same as we have with the h plugged in, which means we just plug in whatever this is, which is x, and we multiply by d over dx of that x. You see that? Then minus the exact same thing as that. Right. So I honestly don't even memorize this. I just always say same with the lower. That makes sense. Those are your questions. So what's this? What's this? Right, so now right now, we're finding the derivative of g. We're not finding the derivative of g prime. We're finding it, we are finding g prime. Yeah. So this would be g prime equal. G prime of dx exactly the same. need to look at their work. They also have a question they want to ask me one-on-one. Right. Okay, one more.